Hello and welcome back. So recently I got a 3D printer, and like a lot of these Chinese kits, they come with stuff that's just, for the worldwide market. So they sent me this power cable to power the whole thing. Just a simple IEC connector, and then there's this European two-prong connector and what Big Clive calls a depth adapter. So you just plug these two in, plug it into the North American plug, and it should work, right? Well, that's fine in principle, but although the power supply is completely encased in acrylic, I still would like to have the ground pin, and the ground pin is just not connected on this one. So I figured I would chop off the end and install a new end. Now this end, I think it cost me $2, so it's better than just throwing away the entire cable. And at the same time, maybe I'll show some beginners how to replace the ends of these things. So I'd like to first preface this by saying that if you're not comfortable with AC wiring, like I wasn't not too long ago, just don't do it. Don't bother. Just throw this whole thing away and get another IEC cable. So these cables are they come with computer power supplies. You can find them pretty much anywhere. So first of all, I will take apart this plug. Two screws here. Okay, so this comes apart, these two pieces like that. And then you take these screws out. That, and the whole front comes off. And then you see the attachment method, which is just basically these little clamps here. So in North America, and you plug it like this. This here would be the ground pin. So this is kind of like a safety device. And then this side here is the hot, and this side here is the neutral. And sometimes you can see that written on here. I see a G for the ground. I see a W for white, and I don't see a B for black, but white and black signifies hot and ground in North America. So white, ground, and X, I guess that's the neutral. But so yeah, this is hot on this side, neutral on this side. Oh, sorry, neutral is white, hot is black. It's a little counterintuitive if you're used to DC stuff. So next thing would be to snip this plug off. Now I don't need this plug at all, so I'm going to snip it really close to the cable here. You can see there are 3 wires in there, so it should be good for running a ground. Okay, and next thing is I'm going to strip a little bit back. So I'm going to take hobby knife here. I'm going to cut the insulation just a little bit. I'm going to try my best not to get into the actual wires, just cut this outer sheathing. Also, if I find that this wire is way too thin, I'll probably throw it away anyways. Let's see here. All sorts of dust came out of there. That's kind of disgusting, but I think it's just the release agent they put so that the wires don't stick to each other. Something like cornstarch, but maybe a bit more industrial. Okay, so now this should be just about long enough. Basically our 3 wires need to go like this, but I'm pretty sure this is the ground here. I think that's what the Euro colors stand for. I think the yellow with green is the ground, and I'm not sure which one of these is which, but there's a way to find out, and that is to check continuity. Pull this one off too. There we go. Okay, so now we're going to get a multimeter and go on from there. Okay, so to check continuity now, I have 2 different leads in my multimeter. I have a clip lead in the red and a pokey lead for the black. I'll put this to ohms, and we're going to start by double checking what we already know, at least what we think we already know. This here, the yellow with green, should be the ground. So I'm going to plug that in there. And then on the IEC cable, ground should be in the middle here. Don't know if you can really see that, but this here should be ground. Actually a little bit of plastic in there, some over molding. Oh yeah, and I'm going to set my multimeter to continuity buzzer. Poke that in here. Is this still plugged in? Yes, it is. Well, that looks like it's not connected at all. I get a connection if I force it, but I shouldn't have to force it. It's definitely not my lead. Well, that just about does it. There's no way I can use this if it doesn't have a ground. Let's check another wire. So blue has continuity. Orange, tan or whatever that is, has continuity. I just snapped my probe trying to force that in there. So there you have it. Not all cords are created equal, and this one here is going straight into the garbage. There are conductors in here that I can use for future projects, but very disappointing that I can't use this as an IEC cable, because even so the ground is in there. I can see the lug, it's just not connected inside here. Well, I thought this would be a better video, but guess not. Thanks for watching. Wait, hold on. I guess I can actually use this, because on this end, sure, I will put the end that I wanted to put on, but on the other end I'll just put the female version and we'll have ourselves a short extension cord. It's better than just throwing this out, so let's proceed. So, as I was saying, this is the ground up here, and I know that the European standard, the yellow and green is the ground. So the first thing you're going to want to do is slide the whole cable through the sheath. Some of them are split, and I don't have a plug on the other side, so technically I don't have to do that, but it's good practice. It's similar to putting your heat shrink on. So here it goes. Just tighten this up. And you want to make sure this is good and tight. You don't want to strip it, but you want to make that extremely tight connection. Now, I'll use this tan color as our white because I feel like it's a lighter color. And because I'm installing both ends of this, I'm the one who's installing both ends, I can sort of pick what color I want to go where, as long as it's both attributed to the same color on both ends. Even so, most things don't really mind whether you pick, you plug it in backwards, but some things will make a difference. So it's best to stay consistent. And right now, I have cut these a bit short, so they're a little hard to handle, but not too bad. Should be able to do this. Get that in there. Give it a nice tight squeeze. The tighter you put it, theoretically, the less resistance you'll have in that contact, and the less resistance means less heat. There's other factors, but that's certainly the general rule. I'm going to twist this all together, shove this in here. You do not want any sort of loose strands hanging out all over the place. That would be bad. So there we go. And I'm trying to make sure pretty much everything is covered. I don't want any of the copper exposed if I can help it. Okay, so now we can put this back together. So the 3 holes correspond only in one way. And the 3 identical screws here, so that would be the 3 long ones. We go back into there. 1, 2, and 3. And those get twisted together, or get tightened, I should say. These don't have to be super tight. In fact, they probably shouldn't be super tight because they're just threaded into plastic. They should be tight where they won't come loose, because this is only safe when it's plugged together. So, okay. And now you're probably thinking, well, if you tug on this and it tugs on the electrical connections, right? Well, you'd be right. And that's what these things are for. These are actually like clamps that will grab the cable and make sure that the load is on the sheathing and not on the actual connections. Put my 2 wires down here. Tighten these down. These have to be reasonably tight because, again, if someone pulls on the cable, you don't want that force being applied to the screw terminal connections we just made. You want it applied to the whole sheathing. And there we go. So now we have a solid connection here. So now over here, I'm going to strip this end, and we're going to do the same thing with this plug. Okay, so I've stripped these back. There's the piece of sheathing I removed. And now we have to open this up, and we'll do exactly the same like we did on the other plug. Just this will be a different, it'll be the female side instead of the male side. I have to say I'm rushing here because I only have 8 minutes left in my SD card. That end pops out, and that looks exactly the same as the inside of the other side. Okay, so I'm going to run this through. Always forget, I should say never forget. I'm going to say always forget. Never forget to put the sheathing over. I have to loosen these clamps. Okay, so we're going to start with what we know. We know that this here has to be the ground because it's the yellow and green. Tighten that down. Get it good tight. Okay, and now my white, which is this one here, is my brown or tan or orange or whatever color that is. Kind of an odd choice for colors. I understand why they don't use red because there's not really an AC, whoops, popped all the way through. In AC, you don't really have a positive and a negative. It's kind of constantly changing back and forth. So I can see why they don't use red, but I don't know why in North America they use black. And I mean, again, it's not positive, but the one more closely related to ground is white. It's not ground, it's neutral, but somewhere in your either your fuse box or somewhere down the road somewhere, it's actually tied to ground. If you turn off the circuit and you check continuity to ground with your multimeter, you will get continuity from the white wire, and the black wire is what we call the live wire, so there's always power going there, or always voltage available there, I should say. It's a bit different. I'm not an expert on AC wiring. Certainly there's some electricians in my family but I do not claim to be the experts that they are. I just know how to replace these plugs. That's almost, I have to say, that's close to as far as I go with AC. It's a little, can be scary. Oh, I got one strand sticking out there. I'm just going to crop it off. I don't want it causing any trouble, even though each one of these compartments are kind of individual. They have separators. Alright, we're going to sleeve this back over. Goes this way. I believe so, at least. Doesn't seem to fit particularly well. Oh, it's because it goes this way. These are cheap plugs. Again, I think they were, each end was $2. You can get some nicer ones, some rubberized ones, some that handle chemical exposure. But these are just pretty run-of-the-mill. Okay, tighten this down. Tighten this down. There's also some with these screws are like speed screws. You don't have to screw them. They don't have a very fine thread. So only a few turns will get them all the way down. I guess it's nice if you're in a hurry. 2 and number 3. Okay, and then I use these clamps here. One and 2, and I'm going to actually mark these for low amperage, just because this cable is from kind of dubious origins. You probably think a cable is a cable is a cable, but that's not necessarily true. Although this cable is rated, at least it has a rating printed on it. It's only worth as far as you can throw it, right? But I'm going to use this only for low amperage situations and while I'm home. Don't know. It should be fine, but you never know. Okay, that's 1, that's 2. Tightened off, and there we go. We turned a virtually useless cable into an extension cord. And if I see that even at low amperage this thing gets hot, well, I can always chuck it into the bin. Well, I hope this video was at least somewhat useful, and as always, thanks for watching.